Here's Precal. I think we could call this lecture part 5 for 5.1.1. It's the last problem in the lesson. And it says, an important application of exponential functions lies in calculating the intensity of radiation from radioactive isotopes by using a mathematical model. Most isotopes emit particles and decay into stable forms. The amount of decay of the particles can be described by the isotope's half-life, which is the amount of time it takes half the isotope to decay. For example, the half-life of bromine 85 is 3 minutes. If you start with 60 grams, 3 minutes later, 30 grams will remain. And how much will remain after 20 minutes? So estimate the answer. So it says if you start with 60, 3 minutes later, you'll end up with 30 because the half-life is 3 minutes. So if you started out with 2, then 3 minutes later you'd have 1. So it's just gonna, half of it will be left every 3 minutes. So they said, how much will remain after 20 minutes? Okay, so we've got 60, and we want to know how much would remain after 20 minutes. Like we know after 3 minutes we got 30. Like I could go like this. 3 minutes. And then I would have 30, right? And then 3 minutes later, hey, I think I can zoom this in. 3 minutes later, I would have 15. And then I would have, well, 7.5. Get the idea? And so I think I did that. I just had my little pink calculator. Remember, they want to know how much is left after. They want to know how much is left after 20 minutes. So really, okay, here's 3, 6, 9. After 12 minutes, I have whatever half of 7.5 is. You know there's a better way than this. This way you could probably understand though. Half of 3.75 is 1.875. And I want to go for 20 minutes and see how much is left. 3, 6, 9, 12, 15. Oh my goodness. So 3, 6, 9, 12, 15, 18, that's 21. So after 21 minutes, there would be 0.46 left. They're asking me to estimate how much after 20 minutes. Well, that's 18 minutes. This is 21 minutes. So I'm just going to say like maybe 0.5, 0.6. I'm going to say 0.6. I'm just guessing. Or I could just say somewhere between 0.46 and 0.93. Okay, that's half-life. So we did all that work. And now they said estimate the answer. So we thought maybe 0.46. Let me do autofocus for you. We said maybe 0.46. And then Lulu thinks that this is the function here. B of x equals, start out, that's the starting point, and that's the multiplier. She thinks that that's the function. B of x equals 60 times 0.5 to the x. She thinks that can be used to solve the problem, but Ishmael's not so sure that her equation is correct because he tried it, plugged the 20 in for the 20 minutes, and it's not close to his estimate, because remember, we estimated our answer should be around 6 or something. So Ishmael asks Lulu, what do your variables represent? And Lulu answers the amount of bromine and time in minutes. So that would be the bromine. Oh no, that would be there's the bromine, and that x is the time in minutes. Does Lulu's equation correctly model the situation if B of x is the amount of bromine and x is the time in minutes? Well, we know it doesn't, because when we plug the numbers in, it actually doesn't work. When we did the problem, we ended up kind of finding out how many half-lives there were. You know what I mean? Like, I knew that in 20 minutes, if a half-life is 3 minutes, I knew I was going to go through 1, 2, 3, 4, 5, 6 half-lives, or 1, 2, 4, 5, 6, 7 half-lives, somewhere between 6 and 7 half-lives. So her equation would work if I know how many half-lives I'm going through. And actually, couldn't I find out exactly how many half-lives I'm going through? Remember, I had 20 minutes and I was going 3, 6, 9, 12, 18, 21, or 3, 6, 9, 12, 15, 18, whatever. I was counting by threes. This was 18 and this was 21. I knew it was somewhere in between, but couldn't I have just gone 20 minutes divided by 3? Every 3 minutes is a half-life. So if I wanted to get really close, I can go 20 minutes divided by 3, and then I would know that there's like 6.66666 half-lives. And then I could plug that into her equation that she had here. See, if you plug 6.666 in here, it works. But if you plug in the actual minutes, it doesn't work. So in letter C, Ishmael responds, but the amount of bromine depends on the number of half-lives, and the number of half-lives depends on the time. We need to write an equation for the number of half-lives. Help Ishmael write the equation of a function to model the number of half-lives given the time in minutes. Well, in our case, we went every 3 minutes was 1 half-life. And to find out, each one of these is a half-life, because that's how many times I cut it in half. Every 3 minutes was 1 half-life. So I could say I have a half-life every 3 minutes, if that makes sense. Because you put your time here, and then the 3 came from a half-life is every 3 minutes. So if I've got 20 minutes to work with, I can divide that by the 3-minute half-life, and that gives me how many half-lives there are. And then I could use Lulu's equation if I want. So this is a little equation so that we could put the number of half-lives in. We could enter in the number of half-lives into Lulu's equation. So help Ishmael write the equation of a function to model the number of half-lives. Given the time in minutes, you'd go time over 3 gives a number of half-lives. And then combine their functions to model the situation where the variables are the amount of bromine and the time in minutes. What function operation do you have to use? Well, hers was b of x equals 60 times 0.5. She had it just to the x. But we found out for the x, you need half-lives. So then that's why we wrote this equation. So we're going to put in t over 3. Or, well, it's going to be x over 3. Actually, let's write it like this. That way, if I put my 20 in, my 20 minutes in there, I get 20 over 3. That gives me my, remember it was 0.666 half-lives. And then if I plug that in to this formula, I'll get my actual answer, which was around 0.6 or something. And then it says, what function operation do you have to use? They want us to say that we used composition of functions, because we had Lulu's function, but right here we had to plug in, what was the guy's name? Ishmael's function. Because she just had an x here, and the x was half-lives, but we needed to write the half-lives in terms of minutes. And so you would go the time divided by 3, because each half-life is 3 minutes. That's all I got on that one.